the goal of this, session essentially is to talk to thought leaders like Nick, see how cutting edge security teams like the one in Snap or the ones in Google or Amazon essentially use open source software at scale to keep their security program, keep their security apparatus consistently cutting edge. With that, to introduce myself, of course, I'm Sandeep, co-founder and CEO of Deepfence. I have Nick with me, security engineering leader at Snap. We spoke about observability. We spoke about Falco's use case. We spoke about the 4 pillars that need to be defined, which is basically what comes in, what goes out, what changes, and how all of this interacts with your existing attack surface. Very specifically, post-deployment, I know you're a large I think one of the largest Kubernetes deployments I've heard of, honestly. We've been speaking to so many large companies, but your scale is very, very different, especially in terms of Kubernetes, really. So tell me more about this. Post-deployment, how important is runtime security observability? And we're talking about the molecules, we're talking about pod level context, process level context, all of that, yeah?
Yeah, let's go deep on this. So think about it this way. You've deployed. Now you've done all the work that you've done pre-deployment that we talked about previously. You've hardened the images. You have ensured there's no malware. You've bootstrapped your pods. Now you're deployed, now you're running. Okay. How do you observe for bad in this running state? And in a immutable service context where a change should never actually happen to a pod because it's meant to not be changed. So you need an observability layer like Falco or like Deepfence that can basically run a kernel level eBPF probe to look for syscalls to the kernel, introspect them and tell you, hey, is this normal or is this not normal? And if it's not normal, fire off an alert. Here's some really good examples. A lot of Kubernetes clusters are targeted for crypto mining takeovers. This happened to Tesla. I've talked about it in the class that I built with Udacity as one of the case studies that we go deep on. They had their API server layer exposed. That actor took over their one or many of their Kubernetes clusters and started spinning up Monero crypto mining pods to do crypto mining. Why? It's free compute. Well, awesome, right? How do you catch that as a big company with a lot of infrastructure going on? Unless you have logs that specifically look for callbacks to their C2 control or other log level observability on the network layer, let's say, you won't catch it at the pod level unless you have pod level observability with something like Deepfence or Falco. You just won't. I don't think there's a way you can technically do it. So to me, this is definitely more advanced, but to me, if you care about runtime and you actually care what's happening while the infrastructure is running before it gets killed, destroyed, and reintroduced, because in this context, we mostly treat this infrastructure like cattle, right, versus like pets. We need the runtime observability. Just like in the corp context, if we have a laptop on the network, I need observability on that laptop, because without observability, I can't react to a malware download on a laptop on the corporate network. Just the same way I can't respond to an event on a pod in the cloud context unless I have that low level observability.
Yeah, absolutely. Yeah, absolutely. So while it is essential to do scan as part of pre-deployment, of course, scan your cloud infrastructure, using agent-based or agentless solution to cover the basics, essentially, CSPM, vulnerability management, all of that. It is equally important to have runtime defenses, essentially, which use eBPF or one of, something similar, essentially, to get you this low-level telemetry and really build detection on top of that, really, right? That's the high-order bit I'm taking away here, Nick. You need both. Scanning comes first, sure. That's a day zero need, but once you have that, you need something which goes deeper, right? And is looking at all of these runtime signals to say whether you are under attack or not.
That's spot on. This is not the start with this kind of thing. This is a graduate from pre-deployment to post-deployment observability. But once you've graduated, this is the next step.
Thank you for listening. You can watch the entire interview at deepfence.io/resources.